Hi, welcome to this video. In this video, we are going to discuss about RAG pipeline. So RAG stands for Retrieval-Augmented Generation. This pipeline will be based upon our previous video, like where we extracted different entities on a legal document. So in the previous video, I will share the link. In the previous video, we'll discuss about legal entity extraction system in detail. So we give the document or the data set and then get these 9 entities. So now in today's video, we are going to develop a retrieval-augmented generation system based upon the previous system architecture or legal entity extraction system, but with some refinements to suit RAG pipeline. So the input layer will be same as before, like we are going to have the same Hugging Face dataset. So I can show you the dataset here. So this is Hugging Face dataset where we get the data and load it and use it for our purpose. So here this dataset consists of different columns. This is in Parquet format, like I already discussed why we go for Parquet format. So Parquet file is a compressor format, and then it is highly suitable for further processing. Especially we use Parquet file format in data engineering side in extraction, transformation, and loading pipeline. So here, this particular A to AJ dataset in Hugging Face, they prepared. Sorry, okay, let me go to the datasets. So they prepared this particular Canadian case law. There are two datasets. One is Canadian case law and Canadian laws. So we are going to use Canadian case law for our demo here. Here, if we go to this particular repository, you can get further details like what is this actually, and I think they are updating regularly this particular dataset. So this is very useful for our use case. The only thing here is that we are going to we are getting the data in the form of parsed, and this is one the data set which is already parsed and then stored in the form of Parquet format. There are different columns available: data set, citation in English, citation 2 in English, name in English, and then document date. So these are the different column headers we have, from where they're also having the URL from where they scrapped it. So if you go open on a URL, this is one particular URL, and then this is a document from where they scrapped it. This is all publicly available. So and here if we see the unofficial underscore text underscore en, this is English text. This is actual text contents in that particular PDF document. So they already parsed it and put it in this particular column as a text, raw text. So in our demo, we are going to use this particular text as a main field to get the entities extracted and stored in the database. So we already have that system, a raw system where we can process and get the data. On top of that, we are going to build a RAG pipeline. The source is same, Hugging Face dataset, and the format is Parquet file format. Here, it consists of different court cases. Like if you see, we are concentrating only on Ontario Court of Appeal. One subset, almost 16,951 cases are there in that particular subset. So we are going to get only this subset of data and then try to work on that one, because I'm going to show the demo in Collab notebook. So for Collab, like this is enough. In the production use case, we can replicate the same with the proper infrastructure. I will explain in detail about that later. So first, let us go to the detailed step-by-step process how we are going to develop. So as previous, we have we have the input layer where we get the data. Since we are going to access Hugging Face, data is already there in the form of Parquet file format. The content what we are going to get only this subset, Ontario Court of Appeal. Yeah, so then there are some common fields available. I already showed you the fields starting from dataset, citation, citation to name, document date, URL from where they scrapped it, and then timestamp and unofficial text underscore en. This is the actual field we are interested in to get the entities extracted from, and then citation to, these are all French. So we have French translations as well. So these are some of the columns available there, and then the next layer will be pre-processing layer, where we prepare the text. So we load the dataset and convert into point of data frame, and then extract the text and clean it, and then we chunk the text as well in order to in order to store in the database. We are going with this particular chunk size. 1000 is the chunk size and 200 is the overlap. Okay. The determination of chunk size depends upon the use case. Since this is a demo, like I took 1000 as a chunk size, but depending upon your use case, you need to play with the different chunk size, and then see which one will give you the correct, appropriate, more accurate answers. Based upon that, you can use that particular chunk size. But for our demonstration, I'm going with 1000. Good enough to get most appropriate answer, and 200 is overlap. So we can further have the chunking, because this is one of the main criteria how you slice the text. If you slice it arbitrarily, then definitely you will lose the information, or the important context might be lost when you are passing into the GPT or LLM for getting the answer, because you need to have a boundary. Either it may be a paragraph, or it may be a semantic boundary, or some kind of thing where it will structure itself as a one particular chunk. Because, for example, if the answer was contained in 2-3 different paragraphs, then you need to pause all these 3 different paragraphs, then only you will get the correct answer. If not, then you don't get. So choosing the chunk size depends slowly on your particular use case, as well as how you determine or how you arrive to this one. It will take some time. You need to adjust based upon your needs, and then only you can able to get this particular correct chunk size, because this plays a crucial role. And apart from that, you need to have a certain boundaries, like from where to where we can take. Either it can be a paragraph, or it can be a context, like whether if the context spills out to a different paragraph, like how you are going to manage. So all those things comes into picture, like when you are actually developing, depends upon the use case. The next one is LLM processing layer. This is where we are going to extract the entities. So in the previous video, we already discussed why this particular entity extraction plays a crucial role in, especially in the legal domain, because in legal domain, most of the documents are in PDF or kind of in the text format only. So if you want to cross-reference any contract or any cases or anything, like for your analysis, it's very difficult. Like you need to manually, or even though you have some system, but you cannot get exactly what you require. You need to compile everything, and then only you can do the analysis. But by using this entity extraction system, even though this is a smaller abstraction on how you can build a high level entity extraction system, here we are just extracting 9 entity types, but still this is so powerful in such a way that you can directly, like, just write a query, like English query, like just give me the case details of this particular clause or particular decisions what it made or something like more uh, like the key points or the key phrases if you give it will lead the database and get the corresponding results. So if you see here we have these entities extracted previously. This I showed in the previous demo as well. We have 9 entities extracted. One is person, the other second one is organization. So these are all on the document. Like once you view the document, from that case document, it will extract person entity type. So it may be appellants, respondents, witnesses, counsel. The second one is organization entity type. It may be companies, institutions, government bodies. Third one is location, cities, provinces, jurisdictions, regions. Fourth is legislation, status, acts, sections, regulations, and case law. And the sixth one is legal topic, like whether it is a contract, a criminal law, tort, or employment law. And seventh one is a judge, what are the judges in that particular thing mentioned, and the court. So in this subset, we are going to go with the ONCA. So I already explained Ontario Court of Appeal and law firm. So what are the law firms representing in that particular case? So now we have these 9 entities. So based upon these 9 entities, if you fire a query, like it will exactly hit the get the relevant details. So once you get the relevant details, then that details with that details and with your query, if you can send it to a further LLM layer or to give the answer, it will be more appropriate answer for your question. So that's what we are going to build here. Here for the third step, once we clear everything and having a chunk size, so we discuss in detail about what is chunk size and why it is so important. Next, we go for the LLM processing layer. This is a entity extraction, like where we do the actual core processing of a entity extraction. Here, I'm using Google Gemini Flash. It is not 1.5. I am using latest Gemini Flash. And then with the temperature, like, I don't want to give more freedom to the particular large language model in such a way that it should not hallucinate. So the temperature, as I mentioned, like this is the parameter, how freely or how creative the large language model can generate their response. So now for our use case, it should not be more creative. So it should be extracting the entities based upon the given context only. So it is more deterministic. So that's why I give 0.1. The parameter varies from 0 to 1. So if it is 1, it is more creative. Towards 0, it is more deterministic. And the maximum tokens 8192 based upon the model we select. And then this prompt engineering. This is one of the important concept in large language model based applications, because the prompt engineering is a concept like how exactly you define or structure your question or your ask to the large language model in such a way that it will produce more accurate and more relevant answer for the question. So this is the way where we give instructions, like we can say we are giving a proper step-by-step instructions to the large language model in order to produce the results. So I already discussed about the chunk size. This is one parameter where we can adjust, and also the prompt engineering. This is one of the important parameter where we adjust or we give the proper instructions to the large language model in such a way that it will produce the high quality results. So it all depends upon how precisely or how accurately you ask questions. And there are different strategies available. That is a different branch where we need to study in detail. But in our demo, I will show you like how I structured the prompt and I give a few examples also to the LLM. So that we call a few short examples. Now with that examples and with that instructions, the LLM will get the context and do the work for us so that it can produce high quality results. As previously, like what we did in our previous video, we are going to extract the same 9 types of entities, that is person, organization, location, legislation, case law, legal topic, judge, court, and law firm. And then we are going to give the document plus the prompt, a set of instruction to the LLM, and the LLM is Google Gemini Flash latest, and we are going to get the output. So we are going to get the output in the form of JSON, and then from that JSON we will get the required entities. So now that is we parse the JSON and get the required entities. Then after getting that, we will parse, validate the JSON, and add other metadata, because we are going to store this in the database, right? So we don't need just the entities. We want for which case it was, and which timestamp, and what is the date, and all the citation. So all this metadata we add to that particular entity response, and then we will store it into the database. So while retrieving, it will be easy, and we will get the exact answer required for the question. And after that, we are going to store it in the database. So in the database, I use SQLite, since this is for a demonstration. But in actual production system, we can go with any production grade database like Postgres or any cloud provided databases. And then on top of this, we are using full text search system sitting on top of SQLite. So this I will show you. Previously we discussed like how we did in the previous video. Here if you see, yeah, this one. So we use SQLite with full text search file. So that is one layer on sitting on top of SQLite. So with the full text search, we can get the answers which is related to that particular query. It will search the full text in the database and get the answers. And also we have table and indexes and all those stuff we discussed in the previous video. The same thing we are going to replicate here. And here we have the different tables, cases, text chunks, entities, and this is for full text search capability. We added this index, and also we have the triggers as well. In order to, whenever there is an update, delete, or insertion of the records, then it will automatically trigger and sync. And finally, we have the query and retrieval layer. So we have some functions defined, pre-defined functions which has the search entities, and then statistics, and then get case of chunks to get the chunks, the raw chunks, if like we want to pass those chunks into the LLM for further answer. So this is a high level overview, and the same thing I represent a different way, like the logical diagram where we have legal drag system architecture. We have input layer, getting the data set, and then processing, LLM processing layer, response layer, response processing layer, and then database storage, and then query and retrieval layer. Okay. So this is how we are going to design, and I will show you the demo, the next part. So we'll switch over to demo. Now we already discussed about the overall architecture, how we are going to implement, and this is a demo part. So here we have this is a database structure, and then what are the capabilities we have in this particular demo. So we have 4 different tables, case tables, text chunks, entity tables, and full text search. Case table, full case documents with text, text chunks, case split into retrievable chunks, entities table, extracted and named entities for those particular case document, and full text chest capabilities, a full retrieval of all, fast retrieval from on all tables. So what are the capabilities we have in this particular demonstration based SQLite database? Store full case documents, chunk text for efficient retrieval, extract and index entities for fast full text search, and RAG ready for LLM integration. So when we have like any RAG system or Retrieval-Augmented Generation system, will work based upon your data. So how well you structure your data and how good is your data. So based upon that only you will get more accurate and more relevant answers. So that's what we are going to build here. Like we build a more appropriate, more structured database in such a way that it can be further integrated with an AI. So whenever a user asks a question, it will generate the answers and give most appropriate answer to the questions. So here I installed required installation required libraries for Google and SQL as well as Pandas, and I'm importing required packages. So here I tested 3 different models, especially latest Flash 2.5, 2.5 Pro latest. We can go with the Gemini Flash latest. Getting the API key. So getting Google Gemini API key, just you can browse and you can search and get that one. Here we can store the API key in the Colab. There is an interface where we can store the secrets and refer here the same way I did. Checking whether the key everything is working as expected. And then we are loading the dataset. So here, as I previously shown, this is the dataset, and I'm loading only the subset ONCA, Ontario Court of Appeal dataset here. It will take some time. It has to get. So we have almost 17,225 cases in this particular dataset. Here we have the dataset citation to name, document date, URL from where they scrapped it, timestamp, unofficial text EN. So this is the field from where we are going to extract. Like it contains all the extracted text in one record for that particular case, and from that, this is the data where we use for getting the entities extracted from. Okay, and all other columns we have, like French. If there is a French translation, we can also find it here. So now we are going to create the database. So here the database name is LegalRag is the database name. We have we are going to create a cases table, text chunks table, entities table, and full text search table for on all tables. Okay, these are the tables we are going to create. So let us create that. So it has been created. Okay. Yeah, it says it was created. You can see LegalDB has been created here. Now, text chunking function. So as I explained in the architecture, this is one of the important parameter how you can set up in such a way that the output will be good enough, or the quality of the output depends upon this parameter as well. Okay. So here I choose 1,000 as a chunk size, and then overlap is 200. So overlap means like when you cut the document in chunks or slice the document into chunks. I'm taking 1,000 characters a chunk size. Sometimes you may miss or It should not slice it in the middle. So for that, I do have the overlap of 200. This is definitely not recommended in a production use case because this will not suffice because we are doing a arbitrary chunking. But in production, you need to figure out a way like how you are going to chunk it. That depends upon the use case. Either you can go with a semantic boundary or having a paragraph level chunking. It all depends like how your document was structured and what is the business use case for that particular retrieval-augmented generation pipeline. So it depends upon that only. You need to figure out how you are going to do because this plays important key role in getting the answers correctly. One of the key roles. And we are splitting the sentences based upon the regular expressions. So getting the chunks, so defining how we are going to do the chunking. And this is how we are going to do the entity extraction. So now I already explained we are going to use this prompt engineering concept. So this is what I'm referring there. Here I'm having a maximum of 30,000 as a length for the text. Since we are going to send 30,000 as a length, set of text to that's a one package sent to the large language model, that is Gemini, that is Flash, and get the entities extractor. Okay. There are certain limits. It depends upon the model you use, how much tokens it can process. So though the Gemini it can process more than this, but I stick to 30,000. That is more than enough for us. So this is a prompt. I'm giving the instruction, a step-by-step instruction, like how you have to behave. So I'm giving the instruction like extract all named entities like person, organization, location, legislation, case law, legal topic, judge, court, law firm, with a detailed descriptions from the following Canadian legal case text. Okay, so I'm giving the example. This is we call this few short example. Entity name like this, entity type and description. Okay, so this is the instruction I'm giving to the large language model along with the text. This is the text in order to extract the entities. Okay. Now processing and loading the cases. Okay. So once we have everything, we need to extract the entities and then process it, right? So here we are having we know the document contains a citation en if unofficial, yeah, this is French, yeah. So yeah, this is citation. Okay, this is a citation, and then this is the unofficial text en. Okay, so from this only we are going to get all the details. Okay, we can change like which one. If you want to French, we can go with French as well. If it is a purely French document, so it depends upon your use case. And then inserting into the database. What are the we already defined the database here. If you see in the define the database, we created the tables, different tables here. Okay, this is a cases table, and then this is chunk table, all that stuff. So based upon this, I'm going to insert into the tables. We already created the database and then tables. So now we are going to run this. Okay. So I defined, I did a modularized concept like everything was separate function, and we call appropriately whenever we need, and then it will do its work. Okay. And now everything was done. We need to process the cases. Okay. I'm going to test it with the first three cases. Let us see how it works. Okay. So processing case 1 2007 ONCA 379. We can just Google it and get the case details if you want. Yeah, this might be the case. Okay, we'll see. Yeah, Court of Appeal of Ontario. Okay. Okay. Can we read the document? Okay. Let us see. Okay, this is the document, I think. Okay, okay, let us see. Okay, so it processed three cases. First one 2007 ONC 379, 38, and 381. So it based upon the data set what we have, on that basis it got three cases and then it processed. So three cases, text chunk 21, and then entities extracted, 56 entities has been extracted. Okay. So this is RAG retrieve functions. Uh, we have RAG retrieve chunk to retrieve the chunk, RAG retrieve full case details, and RAG retrieve by entities. Like if you give any entity, based upon that it will retrieve. Okay, and then get case with chunks. So are all different functions I defined here, and then it has been successfully created. So now let us try one example here. Okay, it's about appeal. Okay, so about appeal, I'm asking like read chunks which mentions anything like appeal. Okay, so we have found five relevant chunks. I put limit as five. You can go for further if you want. In 2007 see a 38 chunk 1 379. I think we have opened 379. Megan Stephens for the respondent. Megan Stephens. We need to get the correct document. Then only we can able to refer, right? Case name. Okay. So what is the document title? Okay, we'll go and see like if we can able to, because we need to get hold of one particular document and then from there we can evaluate the tax system. So in this, so ONCA 38, ONCA 379. Okay, let us see if this one is readily available. Is it RV Wood? Yes, 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 RV Wood. Okay, we got the document here. Okay, so here RV Wood collection decision of Court of Appeal. Okay, 2007 518. Is there any date? We will see. Like we will have that. We will get the entity. Okay. So now the same thing we will try. Instead of appeal, we will see it will get the correct yeah, it is not actually appeal. Anthony Wood. So let us see. Yeah, it gets the correct document. Out of the three documents, it got correctly 379. National Court of Appeal. Okay, okay, okay. So this is retrieving the entities. We can also retrieve, we are retrieving the entities for the judges here. Let us search. Yeah. So that's one thing. We can also go for person. Okay. Who is the appellant for this particular? Mhm. Let me check. Did we correctly define the entity name? Okay, we don't have appellant here. Okay, so we have person organization. Okay, so okay, we'll see the person. I think it will be in the person. It will be in the person. Yeah, we got James Jeepers. Okay, yeah, we have it here. So it is entity type is person, and also we have the description as well. If you see, description appellant in the case, and then James Jeepers counsel representing the appellant. Yes, okay. We have the correct data fetch. So we can get the complete case data if you want. We'll write, okay, get the complete case data, case 2. So, okay, this is the complete case data for that particular uh, case. Okay, yeah, with all components. Okay, so now we can, yeah, so this is a complete, literally complete case document for the first case. So if you see 2007 ONCA 379, okay, let us. Yeah, this one. RB, R versus Wood. Yeah, this one. So we have all the complete case details. I just have, uh, now we can get almost everything from that case. Okay. So from this is how we will get the complete case details from the database. And we can also do the batch processing, like if you want to process more than 10 or 100 cases. Now, here we can also get the database statistics, like how many cases we have, and then see we have processed only 3 cases, and average length, minimum length, and maximum length, text chunks, 21 chunks are there, average chunk size, and what are the entities we have? Like we have 16 count for judge entities, case law 9, person, court, legal topic, location, law frame, organization, and legislation, etc. We can also export the entire thing into CSV and further processing if we need, we can have it. Since we already have it in a database, no need to, like if we need, we can have the form of Excel as well. These are the database tables we already discussed. Now, let us try some examples. Okay, we will try this. Okay, criminal code. Okay, this is how we build the context and then we give the context to the LLM. And then we have a prompt along with the context we send, and we can ask the questions in order to build a complete, like the final RAG endpoint where we will create the context, getting all the chunks, and then with the context we send it to the, along with the prompt we ask the question, and send it to the LLM, it will answer the questions. So now we will try this first. I think we don't have this particular criminal code. We will ask this. Um, what we can ask. Yeah, we just asked retrieve chunks having this name and Antonia Wood. It perfectly went and retrieved the details. Okay, so this is the citation, and then chunk index is 0, and then we get the chunk. Okay, chunk text here. This is a chunk text. So this one we can send it to LLM and answer and ask the question based upon this particular chunk context. Okay. So we saw end-to-end system where we get the documents, legal case documents, and then extracted entities, and then finally stored it in the structured table format along with all metadata, which is very helpful while doing analysis and just writing a query for a required citation, or if you want to search any person, you can just file a query and get all the details about that particular case or the details for that particular class. So we already discussed how we can do that. Like we tried some examples here which work perfectly. So now I want to show you like how exactly it looks in the table format. So I created a CSV file or for each table. So from the cases, text, chunks, and entities. So this is the entity table, how it looks. Here if you see, for this particular case, let us see 2000 ONC 379 citation, where the entity name is location. We will check. Yeah. So we have everything exactly got from this particular document and stored in a structured way. You can see here. So this gives the location. Location, yes. Yeah. So it gives a concise description also of this particular location. Now the same thing we can query. You will see what is the answer we are going to get. Mm. Yeah. Version 10 plus one. Okay. This is so if we try that the relevant chunks, it is this is the correct uh, case citation it grabbed. So there is 379. Yes. Okay. And if we go to the chunk one, okay, we will go to the chunk. This is the chunk. Okay. Chunk one. Okay. Then there's a discussion on positive. Yeah, see, we have that particular detail in case chunk one, and if you go here, this is the citation number, and this is the case chunk one here, and if you see this particular chunk, the chunk is starting from the remainder of this sentence, conditional sentence two. Okay, now if I go here, where I can see the document. Okay, this is the document. Okay, that's it. So where I can, okay, so this is the remainder of the sentence, the conditional sentence style, which is consider the factors of our conditional sentence, but extracted. Okay. Apple appears to record this come the series on the case and okay, that is it. Yeah. Conditional sentence, but action. Yeah, this one. Okay. So yeah, see here exactly. So it retrieved correct chunk, and then we just give the mall name. That's it. The location name. It retrieved correct chunk, and if we can able to post this chunk, so in the final drag system, like in the application where we get this chunk, and then with the question we post to the large language model, it will give you the correct answer. So this is so like accurate, and then we can get the correct details, like depending upon the question. It will get the correct chunk and give you the answer. So these are all the chunks we have for the different cases, and see the rack chunks how much we have. So here it shows like chunk size, start character, end character, all those stuff. Okay, so just I want to show you like how the table looks like, just export into CSV and showing it here. And here if you see, these are the cases, like the entire case details we have. Okay, so see here, this is the one. So we have the entire case details about the particular for the particular case. We have in the form of document. So we get that unofficial text in from the data set and store it here. So this is for further reference. So we have three tables consisting of cases. I can show you here. Yeah, it consists of cases and then text chunks and then entities. So this is just for demonstration purpose I created, and then I show you the capability, like how we can use large language model effectively in legal domain, such that it will drastically reduce the time in order to analyze a case, or get a specific detail from a case, or if you want to compare or do some in-depth detail analysis also, this will be very highly helpful. Yeah, so this particular system what we developed, even though it was um, the abstraction of a system where the features are very limited here, like we just have three tables, and then with this we can able to showcase like how we can effectively utilize large language model in a legal domain, and this will drastically reduce the time required for any case analysis, or we want to do any research on particular case, or on particular judgment, or any in case if you want to refer any kind of document which was backdated with a specific keyword or specific query. Once we have this database set up, everything is structured, and this will be a asset for the particular law firm which deals with the legal domain, or any other enterprise which deals with legal domain. If we construct a database in such a way, then it will be easy for analysis, as well as getting quick insights from the data sets already they have. So this just I want to show you a demo how we can utilize large language model in a legal domain. Hope you get some value from this particular video. Thank you.